Hello guys, a very warm welcome to All India Sri Shivaji Memorial Society's Institute of Information Technology. I am Riyaz Jamadar from Department of Information Technology. I am here to discuss data structure and algorithms. In that one today we will see binary tree creation algorithm. How we can create a binary tree, that is what our agenda. So the agenda is algorithm. What algorithm we are going to discuss? We are going to discuss creating a binary tree. Creating a binary tree. Whenever you pick up any algorithm for binary trees, any algorithm, create, you say create or display or any other operation like finding height of a tree, depth of a tree, normally all these algorithms are recursive in nature, because when we use a recursive algorithm the code will be very less and precise. It will not be a lengthy code. If you make use of iterative algorithms like loops, then the code will be lengthier. So that's why we prefer recursive algorithms for tree data structures. Say now, if you want to create a binary tree, you have a structure with you, say struct such a node. You have to define structure for it. Int data will be there. Then you have links, left link to the left child and link to the right child. Say this is a left and this is a star right. This is how your node is there. From this node you will be creating. What is the first step here now? The first step for it is create a root for it. Create a root, because a binary tree has a root. Then once you create the root, that root must be initialized. For that what we say, read information about, read info about node, like what is the data, what is the left, what is the right. Now while reading info, what you will say, because it is a recursive algorithm, we say, we use a convention here, enter -1 for no data. If there is no data, there is no left child, there is no right child, then you have to say -1. So we inspect the value. If this value is say -1, whatever the user is giving data, say data, if it equals to -1, means there is no child node. So that link should, how that link should go now? We return null. There is no child means we return null. If there is a child, if x is not equal to -1, what we do? We add it as a node in a tree. How we add it? Because we are adding, like we have to say whatever node you have created here, say you can add, create a node, say nn, it is nn data, you will be storing like this x, then it's left and it's right. So how this is interesting here now, nn's left will be, what will be, again we say enter -1 for data. Then if that is -1, there is no left child. If there is a if it is not -1, there is a data. That's why what we do, again we call create function here, call create nn as a left, then say enter right child, and then again nn right will be, again we are repeating the same job. So that way it is nn right create. Then your tree is ready. You can assign or you can return it to, your nn will act as a root here. So your assign nn to root. So your root is a member of your class somewhere. This is how you define a function. Let me give you in coding, like if you want me to take a C++ code for this, how it will go, that I'll show you now. Say here, since it is, we are supposed to return the address, start address, root address. So we say the return type is node star, then we say function create, we don't pass anything. If it is a member of some class, you have to bind it with it. Say if tree bt is your class name, then b colon you have to take like this. say your X data field, then one node v for temporary nn new node, then we'll give the message cout enter data. If the data, there is no data, the nodes are left child or right child, if they are not null, we say enter -1 for no data. This way we are using, it is a just convention. Then you will input that X. If you inspect, if X equals -1, it means there is no node, so you return null here. And then the new node you will create, nn is equal to new node, that you will update. Nn data will be your X. Now what is nn left? Nn left is, again you need to create one more node, so again call create. What is nn right? Nn right, again you need a node, again same algorithm, again recursively you will be calling it like this. So here you can give a message cout enter left child, enter left child of X, you can say like this. And then here cout enter right child of X, like this you can say. Then you are ready now. Your nn itself will become root, so assign root to that nn to root and then say return nn. So recursively whenever you write the algorithm, you have to have a return statement for it. This is how you are able to create a tree. Hope you enjoyed the session. We'll see some more algorithms in the next session. Thanks for watching.